This is Roboy 2.0. It's the second generation of a humanoid robot called Roboy, as you can see. And what makes Roboy very special is that it's a robot built after the human body. So it imitates the human musculoskeletal system, and that gives us a lot of interesting properties for free. For example, the robot is very transparent. So we have force control on each of these muscles, and that's what makes the robot special. It has muscles and tendons rather than motors in the joints. The whole robot is very transparent. So you can really move this around, something like this. You can even use this to shake his hand. And it looks very natural. And it does so because the motors are set up like the human body, and they have this intrinsic flexibility that we are used to from our body. And this makes human robotics interaction very efficient. Also, Roboy is developed in an agile mechatronics process called TAF Agile Framework, which allows us to very quickly and iteratively bring this project forward and make it better step by step and learn on the way. One of the interesting features or products that help us doing this are, for example, this hip. So this hip has not existed like 1 week before it was in the robot. And we didn't design the surfaces in a CAD program and made it look nice. No, we just defined the constraints. We said, here we have a force of 200 newtons going this direction. Here, there's a force from the top of about 2 kilonewtons. We have a bending moment of 140 newton meters, and we need to put motors here. Please calculate a shape. And what it does, it optimizes the shape over time. And after a number of iterations, in this case 67, we have a shape that is only 800 grams heavy, that can be 3D printed, but it's the center of force of the whole robot. So all the forces of this robot end up in this piece, and it's only 800 grams, although the torso, for example, is about 80 kilograms. Also, the robot has a face, and he has it for one specific reason. Because if I'm giving a card to you, we're actually looking at each other to negotiate on how we are passing products on. And this is very helpful because it helps interacting with robots faster. And this is why this robot has a face, so you can look at it and interact. Also, the human constraints of the robot mean that it's more intuitive to work with him. For an industrial robot, there's no difference if it passes something on like this or like this. But for humans, it is. So if I'm passing this to someone, you expect this to come with a human trajectory and not with a robotics trajectory. And this is natural for this kind of system. But ultimately, Roboy is not just the most complex fusion product in the world, but we're also using virtual reality. Guys, are you ready? To train our team and to interact with the robot in VR. We have the software that allows us to show the status of the robot, and when there's some errors in certain aspects of the robot, it's very easy and quick to find out or to detect errors in the robot. Thank you for your attention. If you have any questions, come to us. We're here. Every one of us is wearing a friendly Roboy shirt, so it's easy to see. Thank you.